Hello everyone, this is Balu. Okay, let us discuss about the camber. Right. What is camber? Why we have to provide this camber? Can't we construct road without camber? For all these questions, I will give answers to you. Okay, watch this video until the end. Okay, hope you can gain a knowledge regarding the highway engineering and regarding this topic that is camber. Okay, here you can see the pavement from the center line of the road. You can see the slope here, right? Gradually this you can see from the center line of the pavement. This slope is nothing but the camber. Okay, then why we are providing this camber, right? Because to drain off the water from the surface of the pavement. Okay, what happens if the water stands on this pavement? That picture we can see here. This is what going to happen if the water stands on the pavement itself. You can see the potholes which are like evolves from the pavement, and also you can see the deterioration of the pavement. Okay, this is what the situation when the water stands on the pavement, right? The durability and the surface layers are going to affect when the water is going to stand on the pavement, and also the right, this is also a very important thing. For example, if you are riding the bike on this pavement, when the water stands on the pavement, the skid resistance and also the what is the friction which is generated between the tires and also the pavement will get reduced. If you apply the brakes, then there will be a chance of balance out of your vehicle, and also you can may fall, and also cause of accident will takes place if there is not sufficient skid resistance. This skid resistance will decrease, like when the water stands on the pavement, this water will act as a layer in between the tire and pavement. Thereby, if the brakes are applied, then these brakes will not work properly. Okay, hope you understand this thing. This is also very important thing, that is skid resistance. Okay, in upcoming classes also we can come with the like lateral friction, longitudinal friction, and all these things. Okay, watch this video until this end also, and stay tuned for upcoming videos. Okay, right. What are the types of cambers we can provide on the pavements? That is, first one is parabolic camber, and second one is straight camber, right? When we prefer for parabolic and when we prefer for straight, like it's based on the pavement also, and also the traffic flow condition, right? For example, straight camber in concrete pavement, we basically provide straight camber, because the parabolic camber is, it's very difficult to provide parabolic camber like concrete. While laying concrete, you can basically provide straight camber only. In parabolic manner, you can't mold those concrete pavements. Okay, hope you understand. And also you can see, if W is the width of the pavement, then this height of the parabolic camber, right, that is nothing but W by 2n. Then what is this n? N is nothing but the cross slope we are going to provide, 1 in n. 1 in n is the slope in which we can express 1 in n for when 1 vertical, n horizontal. For example, if you take for 1 meter vertical distance, n meters horizontal distance will be there. In this way, we can express this cross slope or slumber. You can convert this 1 in n into the percentage also. If we consider, for example, 1 in 50 is the cross slope, then in percentage 100 by 50, that is nothing but 2%. In this manner also we can express this cross slope or camber. Coming to the parabolic camber, this parabolic camber equation we can see here, y is equal to 2x square by nw, and you know 1 in n, this n is nothing but here, and also w is the width of the pavement, and x here see, this is the x distance. For example, if we remember, this x distance is measured from the center line of the pavement, and for that x distance, what is the y? Here you can see. In this way, you can express for this corresponding y, you have corresponding x. Y is equal to 2x square by nw. Okay, this is the equation of parabola. That's why from algebra point of view, we can express this like parabolic equation. For example, in question if they are asking at for 0.5 meters, what is the y distance on parabolic camber, then you can directly substitute this x value and n value, and you can get this y value in this equation. Okay, this is what I want to say. Yes, this table is very important. Please remember this table. I will tell the logic how to remember this table also, because from this table they directly ask questions. Like for example, they will give question and they will not ask this value directly, but during calculation, if you don't know this table, then you can't do anything. In GATE, n number of times they ask this question. Please remember these values. Okay, these are the recommended values for as per IRC for different types of payments. And remember, this camber is going to depend on the rainfall condition and also the type of surface. First thing you can see, cement, concrete and thick bituminous surface. Further, in case of heavy rainfall, you are going to provide 1 in 50 or 2%, and in case of low rainfall, you are going to provide 1 in 60 or 1.7 percentage. I already recently said how to convert this 1 in n into percentage form. You can directly divide 100 by this n, then directly you can get this percentage value. For in case of thin bituminous surfaces, you can provide 1 in 40 or 2.5 percentage, 1 in 50 or 2% in case of low rainfall. And waterbound macadam and gravel pavements, you have these values, and also for earth road you have these values, right? These are the different types of payments. Like waterbound macadam and earth road are the not a good quality roads. They are olden types of roads. Like you can see gravel payments also. Directly you can see gravels which are directly like they will provide gravel on the earthen surface, and that is nothing but gravel payment. You basically this observe this type of roads in very olden areas or very undeveloped areas. Okay, and what is the trick to remember these values is, okay, you have to remember 50, 40, 33, right? You can see 1 in 50 directly substituted to here, and 1 in 40 directly substituted to here, and 1 in 33 directly substituted to here. In this way, these values are just a step below, like crisscrossly they will substituted from high to low. 1 in 50, 1 in 50, 1 in 40, 1 in 40, 1 in 33, 1 in 33. If you remember 50, 40, 33, then directly you can substitute in the other place. And remember, you have to remember this 60 and you have to remember this 25. This is a trick I am going to suggest. You have your own tricks. That's also no important. Okay, thank you for watching this video. Like I will come with new videos in the future. Stay tuned for the